Hello, my name is Victor Pastrana. Today's date is 4/9/2026. And this assignment is for FTH223, week 3. For this week's assignment, we're going to be doing component drawings of the recoil spring guide, ejector, and firing pin. For part 2, we're going to be talking about necessary skills, and then for part 3, we're going to be talking about headspace measurements. So we're going to go ahead and jump right in. Part 1 calls for the recoil spring, ejector, and firing pin to be measured or drawn off camera with the specs for it, or the measurements, which I have right here. That this part was actually, oh, that's upside down. There we go. This part is it was fairly easy, so I went ahead and took the length, width, and thickness of each specific part. I saw online that a lot of people are getting this specific firearm confused between the ejector and the extractor itself, and I can see why, and it's because of the design of the firearm itself. This particular one, B6, the sear housing is actually what has the ejector, and I'm pretty sure this is what's happening. People are looking at which one is it? The CM9, if I'm not mistaken, which is pretty much almost exactly the same thing. As you can see right there, it has the ejector, which is 37 on the book itself, but it comes as 2 different pieces, which, you obviously have to put it together to get that the way you want it. All right, so next we're going to be moving on to the importance of reverse engineering, or knowing the necessary skills. And the reason why we drew it out. So for part 2 of this assignment, ask why these skills are important. Reverse engineering isn't just about making a drawing. It's about mechanical literacy. By measuring these parts, you know why behind the design. For a gunsmith, understanding the exact tolerance of a firing pin is the difference between a reliable firearm and a dangerous one that could cause a pierced primer or a failure to fire. These skills are necessary in several real-world scenarios, from troubleshooting to obsolete parts. For instance, when a customer brings in a vintage or discontinued firearm where spare parts no longer exist, you must be able to hunt down a blueprint to the original to fabricate a replacement part. In other words, creating your own spring or somewhere along the lines. Or for customization, if you are fitting an oversized aftermarket part, you need to know the baseline dimensions of the factory components to understand which materials can be removed and which ones cannot be. For instance, with this specific extractor, it obviously can't be removed. It's all one solid part, which just so happens to be the same. Yeah, it's the sear housing. Now, with that out of the way, we will discuss the headspace dimensions. Now, I do have my no-go gauge for this one, so we're gonna put that right there. Now, we can do this without actually putting the firearm together. I would prefer to go ahead and jump right into explaining it. All right, so we have our barrel. We have our slide. Now, for the you want to make sure that it's free of debris. When you insert the go gauge, you want to make sure that the chamber completely locks pretty much. All right, here's the go gauge. So I'm going to drop that down, slide that in, and upon closure, you want to make sure that the barrel itself locks in place, which is letting you know that there is no gap or anything along those lines. So you don't have to worry about the, I guess, pressure buildup and escaping in ways that it's not supposed to. Now, the no-go gauge is pretty self-explanatory. Once you put the go gauge in, or no-go gauge in, and you actually close it, it should not close. So, for instance, I'm not sure if you can tell or see it or not, but there is a gap there. Not a giant gap, but a gap. Now, if that were to have closed all the way, then you have a really, really big problem. So we inserted the go gauge into the chamber on the SARB6. We wanted to make sure that it sat flush, which it did, slightly below the hood of the barrel. Next, we tested the no-go gauge. The barrel should not fully lock up, or in this case, the gauge should sit proud of the chamber, preventing the slide from fully returning to the barrel. Understanding headspace is the most crucial safety check for a gunsmith performs. Why is it so important? Insufficient headspace, the slide may go into battery, or the pressure could spike dangerously because the bullet is being forced into the rifling prematurely. And there we have it. I'm pretty sure that covers step 1, step 2, and step 3 of this week's video. Once again, my name is Victor Pastrana. Today's date is 4/9/2026, and that is it. Thank you very much.